All right, hi. Welcome to a special episode of Math Talk because this is the first one that's in person. I did some interviews in my homotopy type theory, but this is the first Math Talk interview in person. I'm here in my research group's office, which we also call the P Attic. And I'm joined today by Heejong Lee, who's here from the University of Toronto. So you're going to Banff next week for the conference, and then also you gave a talk yesterday for our research group. So welcome. And yeah, do you want to say maybe just start off with a couple words about the sort of research that you do?
Sure, yeah. Okay, thanks for the introduction. So my research, well, let me see. My name is Heejong. I'm from South Korea, and so I study number theory or Langlands program, and in particular, I'm interested in Mod P and P.H.D. Langlands program. So maybe like one way people talk about Langlands program is like there's two different words, and we're like building bridges between these two different words, and like one word is like word of symmetry, one word of continuous symmetries, and the other is a word of discrete symmetry. But for some reason, this word of discrete symmetry has to do with numbers, and there are like infinitely many numbers, and also there are infinitely many prime numbers. So when I say like I think about mod P or p-adic Langlands program, here P means a prime. And it means there are like infinitely many primes, but I'm not good at dealing with infinitely many primes at the same time. So I like to choose one prime and ignore all other primes and work with one prime. Yeah.
So I think technically, I won't say who. I don't want to name anyone, but someone made fun of my supervisor once said at a party that said he wasn't a real number theorist because he didn't let P vary. He just fixes one P at a time.
Yeah. But if you say like P is an arbitrary prime number,
yes.
Arguable.
And I think it was like in good fun. Yeah. So I usually like to start these talks at the beginning. How did you first get interested in mathematics?
Okay, so when I was a kid, so I grew up in Korea, and like right before I go to middle school, my mom sent me like kind of private academy, and it's very common in Korea that like kids go to these academies. So like even after school, they spend several hours there.
So was this like did you already have a strong aptitude for math at this point?
No.
Or this was just a common thing to go to these?
Just common thing, like yeah, it's like I'm going to middle school, so it's like time for study. There's no more fun. So you should go to academy. So I went to academy. And so I was studying. So that academy was big, and it teaches like Korean, mathematics, English, and science. So like also all main subjects. And I was not really good at math at the beginning. I was like at the middle level. And then I was studying there one day, and then for some reason I proved some fact. Like it was very simple. Like it was not like sophisticated proof. It was like maybe one line or two lines proof. But I proved something. I'm not sure why I did that, but I did it, and then like I was like, bomb, like this is something very different. Like I've never experienced this type of argument, and like the rigor in this, probably I didn't know the word rigor at all, but what I felt is that the rigor here is very different from all other things I've experienced. And like I was so excited, and like I think I talked about it to the teacher, and actually very nicely the teacher found it like was very happy about it, and he encouraged me to do this type of thing. So since then, I started to prove every statement I encounter in mathematics. And like I think at some point I started asking my older brother, like, "Hey, do you have some statement I could try to prove?" Because like I'm running out of statements. And like he gave me some geometric, like Euclidean geometric statement, and then like I tried to prove it, things like that. So that's how I started. And
so you really got into the proof side of things kind of early.
Yeah,
I think, you know, lots of people, you know, they go through high school and sometimes
right.
they're really excelling at
Mhm.
mathematics, and then all of a sudden they get hit by the concept of proof and they're like, oh, I thought I
Right.
was good at math and now I don't even know what that means anymore. But you
Yeah,
sort of had this early introduction.
right. I was really into proofs even when I was young, but of course I was not like very rigorous. I remember one time I tried to prove like square root of a plus square root of b is smaller than square root of a plus b.
Mm,
And just like you take the square of both sides and then like compare them,
mm.
and then like I I did it, but actually it's not completely true because like if either A or B equals to zero, then
Ah,
they are the same.
right.
And my math teacher there actually like I proved this and like I think I want some attention. So
Right.
I bring this to my teacher and like, hey, I did this, and like he's like, it's not correct. And so he kind of like taught me how to be a little more rigorous.
Mm,
So I was still like, it took quite a long time to get like
right.
these rigor. I think, I mean, even when I entered undergrad, it was not true that I was like ready to write down very complete proofs,
Right.
but I had like experience in terms of ideas.
Right.
Yeah.
Right. Yeah, I think it's always a constant learning experience of getting more and more rigorous. I feel like there's so many times where I felt like, now I understand how to write a rigorous proof. And then you think harder
Mhm.
about proofs, or you read someone else's proof and you're like, oh, actually, this,
Yeah,
one can be so much more precise yet.
yeah.
Yeah.
And could be very elegant. Like there are
Mm,
tons of different ways of writing a proof.
mm,
And like I think during my undergrad, when I mean either it's a proof or like a solution to an exercise, I was like more into getting a full mark rather than
mm,
creating something really nice argument.
right.
And I think usually my solutions are like so long. Probably like my TAs didn't like me.
Uh, so by the time you started your undergrad, you knew
Mhm.
you were interested in mathematics. You were doing an undergrad in math
Right.
then?
Yeah.
Okay, so yeah, so you decided to go into mathematics. Um, and did you know, like at that point when you were starting your undergrad,
Mhm.
that like maybe you would do a PhD and try and become a
Um,
professor? Like what, or was it just, hey, I like math. I'm doing an undergrad
so well, I was naively thinking I'll do PhD. So I have a older brother who was in chemistry,
now. Hmm.
and like he did very well in like high school, like Olympiad chemistry, and did undergrad, and like so I kind of had a like a sort of role model. So because of that, I thought like, okay, I'll do PhD and I'll try to become a professor. And I didn't really use the word PhD. I thought I'll go to grad school.
Right,
Um,
right.
but I was very naive and I didn't really know what it means. Also, I didn't really think about going abroad for grad school at the time, because like so I'm from Busan, which is like at the bottom of the Korea.
Mm,
So it's like big city, but it's not like Seoul, which is more like a cultural center.
right.
And so like going to study abroad was something I could not really think about,
Ah,
because like there's no one around me did that.
right.
Um, and then I went to undergrad. I didn't have much idea about my future, and I joined the math club, and then there was one senior guy, and like he told us like just go like PhD abroad, and
Mm,
like I was like, oh, okay. It's just like I just came to Seoul, but okay, maybe.
yeah.
And then like these people gave me more ideas about like what it likes doing math
Mm,
for your career.
mm.
And yeah, so that was like how I became a bit more serious.
Mm.
Yeah.
And so, did you start developing a certain taste for
Uh-huh.
like number theory or certain kinds of mathematics in your undergrad, or before that even, or like how did you start coming towards this field and deciding where you would go for grad school?
So I think it very much depends on like whom I am with. Like the people around me give me influence, and like during my undergrad, so there was one really cool professor doing harmonic analysis, and he taught our first year calculus, and like he went way beyond first year calculus, but it was really fun.
Was he teaching you how to do like integrals over the Haar measure?
Not that far,
Yeah.
but the truth is like he covered like some linear algebra, some general topology, and some differential geometry. And like during 1 year, he reached it to the generalized Stokes theorem.
Wow.
So like so we learned about things like differential forms, and but it's so weird. Like I didn't understand it very well. I just like probably I did it in a little like formal way. I could do some exercises, and at the end I did well on the exam. But of course, I cannot say like I understood it very well. Yeah, it's just like I just see how he deal with these objects, and it's just I imitate him, that type of learning. But yeah, still it was very exciting, and I think many people in my undergrad like were influenced by him. So I also thought I'll be one of his kids. So I thought I'll do analysis, but I think like at some point I realized it's not like, I mean, for example, second semester of my second year, I took complex analysis and free analysis, and on both courses I did really well. But I felt like I enjoyed complex analysis so much. I thought it's so, I mean, the theorems are so powerful. It's so surprising. Like when professor teaches complex analysis, he looks like a rock star because he's teaching such a great theorem.
Yeah.
And then for free analysis, like I could do well on the exam, but again, I could not really appreciate these. Like I didn't really get what it means. Was like I didn't gain much understanding. So like I didn't even remember a lot about it. But it didn't really make me stop pursuing harmonic analysis, because well it's like because still I don't really know about anything. But what changed me after was I went to exchange student program in California, Irvine. And then actually I applied. I wanted to go to UCLA because Terence Tao is there, and I thought I'll do harmonic analysis. So like, okay, I'll go to UCLA and learn from Terence Tao. I can do harmonic analysis. But I didn't get UCLA, and I got UC Irvine instead. And then like very fortunately, I met a very nice professor teaching graduate algebra, and he was like he was very kind to me, and I could do some reading courses with him. And so I think if I study with you, I'll study algebra and number theory. So yeah, that's how I started. And the more I studied, it became clear that I like algebra way more than analysis.
I see. So did you have a lot of experience with algebra before that?
No, that was
so your undergrad was like very analysis influenced.
It's a bit analysis school. Yeah, so it was actually first algebra course I took. And but it's like almost at the same time, like I started learning like a bit of commutative algebra and a bit of like algebraic number theory. So it all happened at the same time. Yeah.
Which is, I think, such a great background, though, to set you up for something like the Langlands program, because it is, I mean, it's a lot of things, but a big part of it is, knowing some harmonic analysis and algebraic number theory and something about the intersection of those lines of thought.
But like speaking of Langlands program, is very fun that so when I was in middle school again, I read some math books, and one very influential book was the Fermat's Loss Theorem, written by Simon Singh. like this
yes.
story of Andrew Wiles proving fair mass last theorem with Richard Taylor. And at the end of that book, they say like, oh, this fair mass loss theorem is actually just the beginning of the big program called Langlands program, and some people call this is the grand unified theory in mathematics. And like, of course, I was in middle school. I had no idea what are the objects they talk about. They talk about like elliptic curves. They talk about like I don't know, modular forms or whatever. And then like I don't get those words. And they just say like it's like connecting seemingly very different very different areas of mathematics. And like, oh, that sounds so cool.
Yeah.
It'd be nice like if I become a mathematician, if I study these things, it'll be very nice. So that's what I thought, like kind of naively. But when I was applying for grad school, like subconsciously in my mind, I was like, okay, I think I like to do number theory or maybe algebraic geometry. But I don't, and I like to do something algebraic, but I don't really want to do Langlands program. It sounds so intimidating. It sounds so hard. I want to avoid that. Like that was what was in my mind.
Right.
Yeah.
Right. Yeah. It is very intimidating because there is so much, but there's also, at the same time, for as intimidating it is, I think there's a lot of different ways into the Langlands program. And I think also, I guess different people have different PhD experiences, but I feel like one of the benefits of this group, or like in general, what a supervisor sort of does is like reaches out to this complicated mess and then pulls you into this narrow pipeline, and you just sort of speed learn this thing, and it just all of a sudden you get teleported into it, right?
Yeah. Yeah, I think it was also like that for me.
So when you were applying, you you were sort of intimidated about working in the Langlands program. So then like what happened when you got accepted? Did you do a master's first, or is it straight to your PhD?
No, it was the PhD.
Okay. So then when you applied to University of Toronto, did you have some people in mind? When you got accepted, did they give you a professor right away, or did you decide after?
So I did have some people in mind. I mean, but it's not like it's not that I understood what they were doing,
right?
But just like there were some criteria. Like, I mean, again, I wanted to do some number theory or algebraic geometry, and even if it's number theory, I like to do something algebraic. And some other things were like I thought I should apply to places where there's like at least 2 or 3 people that I would like to work with. Because you don't know, like you apply and then like what if the person you're interested in just move to somewhere else?
Yeah.
So,
or even if you don't end up getting along, right? Maybe you get there and then in your first year you're taking a course with someone else in that area, and you just find some connection with them and what they're doing. Then I think it's good to have those options in mind.
So that, and also I thought it's nice to have some like big community that I can work with. I thought that'd be nicer than like just working alone. And also I thought like I would prefer working with some like relatively young professor. For some reason I thought that's important. And so I had some people in Toronto in my mind, and I got Toronto, and then I took a course of my supervisor, and he was very nice to me. Actually, there's one episode that I always tell people. So like, I took one time. So I was taking his course during the first semester, and then like one time we took the elevator together. So it was just like me and him, and then like he turned to me and said something, and like I did not get what he said. So like in my mind, it was like, wait, what did he say? And my mind was like, it was like at the speed of light. I was thinking, wait, he said something in Korean. Wait, he said, how have you been in Korean? And like that just like passed through my mind, and like I was so shocked. And I could not say anything. So that was a very, very nice interaction with him. And it turned out that like he knows a little bit of Korean. So yeah. So yeah, and I guess like so at some point I decided to work with him, but even at the time, it's not that I had good understanding on his subject.
Right.
I mean, so I think many people say like, how do you choose your research area? And then one easy answer is you don't choose your research area, your supervisor choose. Yeah. So that's how it happened, sort of. Yeah.
Yeah, I think for some people they're committed, you know, they have a pretty strong idea early
Right.
on, but I knew for myself I liked a lot of different things, so I knew, yeah, I'd apply some places, some interesting words in someone's description, and I knew wherever I ended up, it'd be okay, I'll be happy. Yeah.
Yeah. Yeah, I thought like there, I mean, I many times I wonder, like, let's say I am interested in a certain subject, but like, is that feeling really correct? Like what? And because what I know about this subject is way less than what I don't know about this subject. As at least as a beginning graduate student. So I didn't like think too much about like what specific area I want to work on. But yeah. So I think I was okay with like whatever my supervisor is doing. And I mean, and also it looks very algebraic. So yeah, that was I think, and I'm glad it turned out well. Yeah.
So now you would say you have a better understanding, much better understanding of the area. You're at the end of your PhD now, right?
Yeah.
Do you have is your thesis defense planned already, or
Not
still
exactly.
working towards that?
Yeah, I guess like I'm waiting for the my job application result.
Right.
And I think after that I'll think about defense and so on. Yeah.
Right. And so maybe you can say if you want to even use the board. We don't have to go into severe detail,
technical things. Yeah.
So do you think that you'll stay largely in what you've been doing, or is there different ways you think you might branch out? I mean, maybe it'll be affected by where you end up as well to some extent.
I think I think that's true. But like it's like I like learning different mathematics, but I also think there's a very limited capacity of mind, and I don't expect I can like branch out a lot from what I'm currently doing. Yeah, it's like
that's a difficult. There's too much interesting mathematics. There's too much interesting things in the world. Pierre, do you want to talk about?
I'm okay.
Okay. There's too many interesting things in the world, period, to all the time I'm looking at some interesting document and I look into the field, I'm like, oh wow, this seems like such a cool field. And then you look at everything you need to read to understand it, and it's like, okay, I have work to do. And I have other interesting math I'm working on. I should work on that. Yeah.
Yeah, that's like one of the most difficult part of doing math, I guess. Yeah.
So I guess excited for the future, and so I know getting a postdoc, you just often you throw out a ton of applications and see where anything lands. It's hard to plan around that, but do you have any dreams of where might be nice places to go, or particular people?
I would not comment on this.
Okay.
No comment. I think future is uncertain, and I'm open to possibilities.
Sure.
I think it's like bad and good part of academic life that you don't have like very concrete idea where you will end up being. And like there are moments that I really hate this fact, and sometimes I like it. And
yeah, I like the fact I like the idea that when it comes time to do postdoc positions, that I'll not just be traveling, but then spending significant time in presumably other countries, and then it's a chance to pick up some language, pick up some culture, to be there than more just on a vacation. So I do really like that idea, but yeah, it's also unsettling to think about where you end up more permanently that you don't have so much control over.
Yeah. I think like I'm not sure how other people feel about this, but at some, like, for example, when I was applying for grad school, this fact that I don't really know where I will end up, like, gave me like very huge, like, great sense of insecurity. And I was actually very nervous about it. Like, would I like adjust well to the new environment? And yeah, because I guess it was like a bit related to some of my previous experience. Because like during my undergrad, it was I did 2 years of undergrad, and then in Korea you need to serve in the military as a mandatory. So I did military service. So I was kind of like I was away from the society. I was in a completely different society for almost 2 years, and then I went to California, and then I came back to Korea. So like during that time, it was sort of like too many transitions in my life.
Right.
And I was like, I felt I don't have like a concrete ground to stand on. So like, but also I was planning to apply for PhD, and it was not an easy decision at the time. Like, yeah. But also I thought, like, once I go there, and then it will get better and better, and it has been better and better. Yeah.
So yeah, was there a bit of an initial shock, like culture shock or adjustment coming, or do you think that maybe even having traveled around a bunch right before your PhD somehow made the transition easier because you were already going through these?
I think it was definitely easier than the first time I went to California. And I wouldn't say like it's really a culture shock or something, but okay, it's been a while. I thought about these difficulties, so I'm not sure how I should say it. Okay, maybe we can move on.
We can move on from that. Yeah.
I can say more about it when I can recall some of my feelings from the past. Yeah.
So one question that I normally ask towards the end of the interview, which is this is a total curveball from everything else, and it's a terrible question to ask at the end of the interview because it's somewhat deep. But what is your stance on the philosophy of mathematics? Do you think it's created, it's discovered? Do you think it's real? Do you think it's fiction? Where do you land, or I even recently had a guest who thought in some sense it was a non-question. So
well, I guess, like, I mean, for example, if it is created, like, what does that mean? Like, what does it mean to you, for example?
I mean, for me, so I'm very much in that camp. So for me, I see mathematics as not some sort of objective feature of the universe in which we live in. I see it as much like a language created by humans, and I think in some sense, yes, there is a discovery because we set up the axioms and we set up the questions, and then we go out and find out. But I think it's still something of our making. It's not in the sense of the like electrons pushing back on my hand are somehow more real. Yeah.
So maybe it's not really answer to your question, but the way how I feel about mathematics is that it's it is like a whole new word. Like, I mean, like people say like physicists think about the universe, and like and then mathematicians think about like every possible universe. And I think that means like physicists, I mean, there's like this physical reality, but maybe like in mathematical reality, you can just like think about something does not even reflect the physical reality. And like of course there are questions of like whether such thing is meaningful or not. But if you are not worried about like whether it's meaningful or not, you can just have fun with, you can just create, you can just think about any weird setup and work with it. And but the way how I feel about this is like, for example, you know, mathematics, like these weird concept in mathematics is not the only abstract thing in our life. Like, for example, we in our real life we talk about emotions, and emotion is very abstract. Or like you can say like, or people talk about religion, talk about God, and those are also very abstract. So like, can you like touch, let's say love, can you touch love, can you feel love, like what is love? And there are all these questions, but at the same time we all sometimes like feel it, and like there's a sense that like you feel such thing exists. So there's this like whole physical word and whole abstract word that we cannot really enter. But I feel like when I do mathematics, sometimes it allows me to enter this abstract word, and I think about all these abstract stuffs, and like even things like imaginary number I, you can ask like, does this number exist or not? But like whatever it means by it exists or not, I feel it exists. I feel like, you know, it's like emotion. Although I cannot touch it, I cannot see it, I cannot taste it, but when I enter this word, I can totally feel it. It's there. And that type of feeling is like the biggest reason why I study mathematics, because I feel like I belong to this place. I belong to this world of abstract things. And sometimes I don't really feel like this physical world is real. Actually, that abstract world is real. I want to go there, and mathematics allows me to travel there. Yeah.
Well, that's a fantastic answer. And I think maybe a wonderful thought to leave everyone with, to take with them. So thanks everyone for watching, and thank you for being here and chatting with me. And yeah.
Thanks so much.